Welcome to Spring LIB.
Hello. In the question we have given that a square-shaped coil has following. So we have given the resistance of the coil, that is 104 ohms. Then N is given, that is equals to 50 turns. Then further we have given an area of 1.5 into 10 raised to minus 3 meter square. So area is 1.5. It is 1.5 into 10 raised to minus 3 meter square is given. The coil is placed in a magnetic field parallel to the normal of the coil. So the coil initially is placed in this way. So if this is the coil, so this area vector of this coil and the magnetic field is parallel to each other. So this is the condition. So this is B and this is N cap. Then further, so they are mentioning that then the coil is rotated at an angle of 90 degrees. So if the coil is rotated in the 90 degrees, so this coil becomes somewhat like this. So this normal is coming out of the page. So this normal comes out of the page. So this is N cap and the magnetic field is in this direction. So that the normal becomes perpendicular to the magnetic field. That is what we have represented over here. So a charge of 5.9 into 10 raised to 5 coulombs is given. So the charge is equal to 5.9 into 10 raised to minus 5 coulombs is given. Flows in coil during rotations. So find out the magnitude of the magnetic field. So we just have to find out the magnitude. So we will use over here the Lenz's law. So according to the Lenz's law, the EMF induced is equals to minus d phi b by dt, where phi b is equals to b dot a, that is magnetic field dotted with this a. So phi b from here turns out to be ba cos theta, that is the angle between this one. So if I rearrange this equation, so I get this EMF times dt is equals to minus db d phi b, sorry, so this will be d phi b, that is flux, magnetic flux. So now I, this epsilon, I can write it as IR times dt, that should be equal to minus. So actually here we should plug one n also, because they have mentioned the number of turns as well. So this should be minus n. So here I should put minus n. So here it will be n. So this is the change in flux. So it will be delta B. So flux final minus initial flux. So now we will integrate. So first let us plug the value. So IR dt is equals to minus n. So now final magnetic flux will be 0, because cos 90 is equal to 0. So this one turns out to be 0. So it will be b dot a, so into cos, or just ba, we will not put a dot then over here. So it will be ba cos 90 minus ba cos 0. So this goes to 0 and then we just have this. So I get minus minus becomes plus. So and here I will plug, because this area is changing, so I will write dA. So now if I integrate on both the sides, I get integration of IR dt is equals to minus n integration of, so minus minus turns out to be plus, integration of b dA. So now if we just plug, so I dt is q times r, that is equals to n b a. So we have to find out magnetic field. So this will be b is equals to qr divided by n times a. So q is given, that is 5.9 into 10 raised to minus 5 into the resistance value is 104 divided by N is 50 into area is 1.5 into 10 raised to minus 3. So if I calculate, I get the magnetic field as equal to 8.1 into 10 raised to minus 2 Tesla. So I hope you find the solution useful. Thank you.